Yeah, you have all the accesses, Mr. Biswas. Can you please start? Thanks.
Yes, yes. Am I audible?
Yes, you're audible.
So can I
Can hear
request
you.
the organizer to present, move my slide?
Yes,
I have already.
we can do it for you, or if you want to share your screen,
No,
it would
no.
be great.
Please move my slides, which is
Okay,
there with
we
me.
will do that for you. Thanks.
So this part I have covered. Please go to the part. Social entrepreneurship. I think I have covered this outline and social entrepreneurship. So straight away go to research objectives, because that way I can save time. Go, please. Please go. Next. Next slide. Yeah. Just before slide. Before that. Just move back. One slide, move back. One slide. Research objectives. Yes, research objectives. Okay. So, am I audible, right? Am I audible, right?
Yes,
Not here, sir.
yeah, we can hear you loud and clear. Thanks.
Can you hear me?
Yep, can do.
So, the research objective was to identify the critical issues for social entrepreneurs in Industry 5.0. Hello? Am I audible? Hello? Am I audible? Hello? Am I audible?
Yes, you
Am I
are.
audible?
Yes, you are. We can hear you loud and
Am I
clear.
audible? Hello?
Yes,
Hello,
you
am
are.
I audible? Yes. To identify the critical issues of social entrepreneurs in Industry 5.0. That is the main subject area. And here we are proposing a novel framework of PQ, quasi-rank, orthopair, fuzzy sets. Next. Next slide, please. The contributions is that it is a kind of distinguished contributions, critical issues of social entrepreneurs, novel extension of PQ, quasi-rank, ortho with exponential logarithm aggregation. It is a decomposed version and we are extending Foucault method. Next. Next slide, please. So decomposed fuzzy set is a recent addition to the domain of fuzzy set that considers two perspectives. One is the optimistic, that is the functional perspective, and second one is the dysfunctional, that is the pessimistic perspective. Go to the next slide, the thing should be clear. Next slide, please. Next, if you look at this figure, it is a picture. Go back. It is a picture of a bottle which is half filled and half empty. Now, you can see the two views are there. One is the functional view that says the glass is half full, and the dysfunctional view says that the glass is half empty. This we call it as a optimistic and pessimistic view. Now, traditional fuzzy set only considers membership function, and gradual movement of to intuitionistic fuzzy set that considers both membership as well as non-membership function. But the advanced version of decomposed fuzzy sets that considers this membership and non-membership function from both the perspective, optimistic and pessimistic. Next slide. Next slide. So this basically gives rise to our model called decomposed fuzzy sets, which is basically considering two real numbers, that is P and Q. Basically, intuitionistic fuzzy set has a problem that mu plus V, that is the membership plus non-membership function addition, sum, has to maintain the inequality 0 and 1. Now, in case of this PQ quasi-rank fuzzy set, classical PQ quasi-rank fuzzy set that uses two natural numbers P and Q, and by adjusting the values, it maintains the inequality with a wider flexibility. Now, we have adapted this concept of PQ quasi-rank orthopair fuzzy in case of decomposed version, where there are two membership function. One is the functional membership, one is the dysfunctional membership. There are two non-membership functions. One is the functional non-membership, one is the dysfunctional non-membership. And accordingly, they maintain the range from 0 to 2. And on the screen, you can see the definition of score function and departification, which we have modified of the classical definitions given by the Kahraman 2024 and Palpandi 2025. And this is the aggregation operator which we have modified and developed a new one from the both perspective, functional and dysfunctional. Next. Next slide, please. Now, FUCOM is a pairwise comparison method developed by Pamukar and his colleagues in the year of 2018. It actually tries to find out the criteria weight or the attribute weight through pairwise comparison, just like the method called AHP, very famous method called AHP. Now, comparing to AHP, FUCOM offers a number of advantages. The first one is the lesser number of pairwise comparison. FUCOM only requires n-1 number of comparisons compared to AHP that requires n into n-1 divided by 2 number of comparisons. There is another method called BWM, Biswas method, that requires 2n-3 pairwise comparison. So compared to all these methods, it provides a lesser number of comparisons. That means the computational complexity is less and better handling of subjective bias. And also it has a advantage of inherent mechanism to check the deviation from consistency, which we call DFC, and it can handle large number of criteria. Next. Next. To understand this FUCOM methodology, first it starts and then it tries to compare each pair. Now, when it comparing each pair, it basically assigns, it gets a number called comparative priority. Now, the consistency is achieved when this comparative priority of, let's say, C1 with respect to C2 is exactly equals to the weight distribution is W1 by W2. And this difference has to be equals to 0. If this difference is not 0, that means comparative priority is not consistent with the weight. That means there is an inconsistency. So that this difference, next slide, this difference, next slide please. This difference is set as an objective function which is called psi, and the objective is to have this minimize this difference between this inconsistency. So that we solve using the software called Lingo, and FUCOM also offers a property of mathematical transitivity. Next. Next. Next slide, please. This particular paper, we have taken the views of 12 experts, which is satisfies the Kendall's 1948 requirement of group decision making. And these experts are mostly social entrepreneurs, and also some of the government officials are there, and also academic, 1 or 2 academic persons are there. And they have a varying level of expertise. We have used a 7-point Likert scale with the values are given on the screen. Next. So we identified 10 such challenges that social entrepreneurs face in the context of Industry 5.0. These challenges are identified through reviewing the allied literature, as well as in series of informal discussions with the field workers, social entrepreneurs, and government officials. Next. Next slide, please. So this is the response that we have obtained from the experts. Next slide. And when we use this parameter setup, there is the p-value 3, q-value 2 as suggested in the literature. And then we set the parameter for exponential logarithmic aggregation as 2. We have assigned equal importance to all the experts. So the weight for each expert is 1 by 12. And after using our proposed aggregation operator, we calculated the score using our developed method, and we get this score. This scores we use for pairwise comparison. Next slide. Next slide, please. When we pairwise comparison, you see that challenge 9 and challenge 2, they are when they are compared, then it's the value of CP, that is the comparative priority, comes out to be 1.0322. It means challenge 9 is 1.0322 times of challenge 2. Now, ideal case is that if their proportional weight values ratio is equals to 1.0322, then it basically is a fully consistent. And if it is satisfying the transitivity property, that is, if challenge 9 is 1.0322 times challenge 2, and challenge 2 is 1.0635 times challenge 10, then challenge 9 is 1.0322 multiplied by 1.0635 times, that is 1.0977 times of challenge 10. So if it satisfied all these conditions, gradually it builds a model, which we showed earlier. And if we solve this model, we get the value of objective function, which is in our case, it is very negligible. So we can say the decisions that is the pairwise comparisons are inconsistency. And accordingly, we get the weight. Then next. Next. Based on the weight, we rank the challenges.
Sorry to interrupt you, but can you please manage your time? We have 1 minute and we are going to have Q&A.
I just complete in 1 minute. I just complete.
Thanks.
So we did a comparative study with classical other models. Next. Next. Next slide, please. Next slide, please. Hello. Next slide. Next slide. Okay. Just go back. We also did sensitivity analysis for varying the parameter changes. And what we have noticed that, go to the discussion slide.
Presentation right now. The next presenter is Mr. Bilni, actually. You have the access right now. You can actually present your presentation. You can share your screen or share your slides if you want to. Are you with us?
The last slide.
Do you have any question?